July 1, 2022. This morning Venus passes Aldebaran in the east-northeast before sunrise. In the evening, the thin crescent moon approaches the Sickle of Leo. Chart caption, 2022, July 1st, 1 hour before sunrise, Venus is to the upper left of Aldebaran. By Jeffrey L. Hunt. Chicago, Illinois, sunrise, 5:20 a.m. CDT, sunset, 8:30 p.m. CDT. Check local sources for sunrise and sunset times for your location. This is the last day for the latest sunset time that began June 22. Daylight has already lost 4 minutes since the solstice over a week ago. By month's end, daylight is shortened to 44 minutes. Sunset slides back to 8:10 p.m. CDT in Chicago. Morning sky. This morning is the Venus-Aldebaran conjunction. Venus continues to step eastward, now passing the stars of Taurus. 1 hour before sunrise, find the morning star about 8 degrees above the east-northeast horizon. The bright star Capella is 27.0 degrees to the upper left of Venus. Chart caption, 2022, July 1st, through a binocular, Venus and Aldebaran are easy to see. Can you find Aldebaran, 4.1 degrees to the lower right of Venus? If it's not visible to the unaided eye, try a binocular. The Hyades star cluster might be visible as well. Venus continues to open a gap to the 4 morning planets. This morning the Venus-Saturn gap is over 105 degrees. When the gap to Saturn opens to 180 degrees, Saturn sets as Venus rises. The Venus-Saturn opposition occurs August 28, leaving 3 planets in the morning parade. Chart caption, 2022, July 1st, Saturn is in the southern sky before sunrise. At this hour, Saturn is about 1/3 of the way up in the southern sky. Saturn is the dimmest of the 4 bright planets in the sky this morning. It is retrograding in eastern Capricornus, near the star Deneb Algedi. Earth is quickly overtaking Saturn, passing between the planet and the Sun on August 14. The ringed wonder appears farther westward each morning as Earth catches up, but Venus is speeding away from Earth. The combination of movements widens the gap each morning. Chart caption, 2022, July 1st, 1 hour before sunrise, look for Jupiter and Mars in the southeastern sky. Bright Jupiter and Mars are between Saturn and Venus. The Jovian giant is easily observed about 40 degrees up in the southeast at this hour, while Mars is marching eastward and away from Jupiter after their conjunction at the end of May. The red planet is nearly 20 degrees to the lower left of Jupiter, about 1/3 of the way to Venus. Seemingly, Mars is too dim as we perceive it as a bright star in the sky since it is so close to Earth. The planet is small and somewhat non-reflective, resulting in a dim planet in the sky. This morning Mars is 120 million miles away from us, while Jupiter is nearly 4 times that distance. Watch the gaps continue to open, Venus to Saturn and Mars to Jupiter. Evening sky. Chart caption, 2022, July 1st, the crescent moon is in the western sky near the Sickle of Leo. 45 minutes after sunset, the crescent moon, 8% illuminated, is nearly 15 degrees up in the west-northwest. It is among the dim stars of Cancer, but they are difficult to see. The Beehive star cluster is in the same binocular field as the moon, but its low place in the sky makes for a difficult study. Photo caption, 2020, April 26, the crescent moon with earthshine appears near Venus as the brilliant planet approaches the star Elnath. The moon is exhibiting earthshine, sunlight reflected from Earth's oceans, land, and clouds, that gently lights the lunar night. The star Regulus, over 20 degrees up in the west, is 18.3 degrees to the upper left of the lunar crescent. It is part of Leo's head, also known as the Sickle of Leo, a farmer's curved cutting tool. Chart caption, 2022, July 1st, the summer triangle, Vega, Altair, and Deneb, is in the eastern sky after the end of evening twilight. After the end of evening twilight, about 2 hours after sunset, look to the eastern sky. The summer triangle, Vega, Altair, and Deneb, is there. Each week it is farther westward. By late fall the triangle is low in the western sky. Here in early summer is how the 3 stars receive their informal name, summer triangle. The pattern is in the eastern sky as night falls. Vega is the 3rd brightest star visible from the mid-northern latitudes, after Sirius and Arcturus. Its sapphire white color indicates a high temperature. It's only 25 light-years away and shines with an intensity of nearly 50 suns. Like the planets, the Sun and other stars revolve around the center of the Milky Way galaxy, taking over 200 million years for one galactic orbit. The Sun and Solar System are at a distance of 27,000 light-years from the likely black hole residing at the galaxy's core. When we look into the night sky, the Sun's revolution around the galaxy is generally toward Vega. The spot we are heading is to the southwest of the star, in the constellation Hercules. Vega is the bright jewel in the diminutive constellation Lyra the Harp, made of 6 stars that can be seen from most backyards. The pattern looks like a parallelogram connected to a triangle. Epsilon Lyrae on the chart, is sometimes referred to as the double star. Through a binocular, the single star breaks into 2 stars, a double star. Through a telescope, each of those stars is a double star, a double. The remnants of an exploded star are visible between Salafat and Sheliak. Catalogued as Messier 57, M57 on the chart, and known as the Ring Nebula, the relic resembles a faint smoke ring through a telescope. Photo caption: The Ring Nebula, NASA/Hubble Space Telescope. Astronomical theories predict that some Sun-like stars burst open when they are nearing the end of their stellar lives. The core is no longer hot enough to fuse simple atomic nuclei into more complex matter, and the gravity is not strong enough to hold the outer layers in place. Unlike a supernova of heavier stars that explode and scatter their shattered remains into space, these stars kind of hiccup and send their layers outward. The hot core, known as a white dwarf, remains at the center. The cinder retains mass that is about equal to the Sun, but is crushed into a globe the size of Earth. Some observers call that white dwarf the nebula's central star. My observing colleagues have searched for telescope sites with no street lights or the glow of nearby cities to attempt to see that faint star. Through telescopes with cameras to capture the nebula's faint light, long-time exposure photographs capture the expanding gas that was once the star's layers along with that central star.